Hello everyone, welcome back. In previous lecture, I started new chapter that is about the system of limits, fits, tolerance and gauging. Let us recall about it. So the first I explained about the various terminologies, what is interchangeability, then the limits, then what is allowance, what is tolerance. Okay. So the syllabus, then the interchangeability, limits of size, allowance, nominal size, basic size, actual size, tolerance, tolerance zone. Then in today's lecture, we will move on further. Before that, I will explain again about this tolerance zone. So here in the figure, you can see it is the zone between the maximum and minimum limit. Here you can see this is the tolerance zone. So this is the upper deviation and lower deviation. The difference between both is known as the tolerance zone. Here by the dashed line it is shown in the figure. Next is the upper deviation. So it is the algebraic difference between the maximum size and basic size. Here there is the maximum size and this is the basic size. Here you can see the basic size. So this is the basic size and this one is the maximum size. So difference between both is known as the upper deviation, and upper deviation of whole is represented by symbol ES, that is the Ecart superior, and of shaft it is represented by the small es. Okay, now the lower deviation, it is the algebraic difference between the minimum size and basic size. Here you can see this is the minimum size and here it is the basic size. So the difference between the minimum size and basic size is known as the lower deviation. Now, what is actual deviation? So, actual deviation is the algebraic difference between an actual size and corresponding basic size. Actual deviation is the algebraic difference between the actual size and corresponding basic size. Now, what is actual size? Actual size is the actual when we measure the part, and the size we get is the actual size. And the basic size, what is basic size? Basic size is sometimes also the nominal size which is taken as the reference. Now the difference what we get, the variation, that is called as the actual deviation. Now, what is mean deviation? So, mean deviation is the arithmetical mean between the upper and lower deviation. There is one particular upper deviation and lower deviation. The arithmetic mean between both is the mean deviation. And then the fundamental deviation. The what do you mean by fundamental deviation? Here it is one of the two dimension deviations which is conventionally chosen to define the position of tolerance zone in relative to zero line. Now, what is zero line? Zero line, here you can see over here the basic size or all the lower deviation and upper deviation are given from this zero line. So, the after basic size, the fundamental deviation is provided, and it is the one of the two deviation which is conventionally chosen to define the position of tolerance zone in relative to zero line. So, fundamental deviation is used for showing the tolerance zone and its position where the tolerance zone starts. So, that is the fundamental deviation. Now, we will discuss about the various types of fits. What is fit? First, let us discuss. So, fits is nothing but the degree of tightness or looseness between the two matching parts is known as the fit of part. The degree of tightness or looseness between two matching parts is known as the fit. Now, the nature of fit is characterized by presence and size of clearance and interference. So, what is the nature of fit? Nature of fit is the presence and size of clearance and interference fit. Now, the term clearance defined as the amount by which the actual size of shaft is less than the actual size of matching hole. So again I am repeating, what is clearance? Clearance is the amount by which the actual size of shaft is less than the actual size of matching hole. So suppose this is the actual size of shaft and here is the actual size of hole, and we can get there is a clearance between both of them. There is a space between them when we assemble them. So that is the clearance. Now the in other words, the clearance is the difference between the size of hole and shaft before assembly. So the difference between the hole size and shaft is known as the clearance. So this clearance must be positive. Okay. So you can see the clearance will be always positive and it should be positive. Otherwise it will turn to another type of fit. This is the first clearance fit. Now we will see what is interference fit. So the first, let us define the term interference. So what do you mean by interference? So here it is defined as the amount by which the actual size of shaft is larger than the actual finished size of matching hole in an assembly. So the amount by which the size of shaft is larger than the actual size of matching hole. It is completely opposite of the clearance, in which the shaft was smaller, but here the shaft is larger than the hole size. In other words, the interference is the arithmetic difference between the size of hole and shaft before assembly. Same way, as we took the difference between the hole size and shaft size, we get the clearance fit if it is positive. And if we take the difference between the hole size and shaft size, if the difference is negative, we will get interference fit. Again, I am repeating, if we get positive difference, that means clearance fit. And if we get negative interference, negative difference, then we get interference fit. Now let us see another type of fit, that is the transition fit. So what is transition fit? Transition fit is the fit in which we get perfect fitting of part or tight fitting of the component. That is called as the transition fit. And for transition fit we require some external force to fit the part in the hole. For example, in ball bearing, the bearings needs to be pushed in the braces so that it can fit perfectly. So that is one example of transition fit. So this is all about the types of fits. Uh, Here again it is mentioned about the types of fits in detail according to Indian standards. So the first fits are of three types as I explained. First one is what is clearance fit. So in clearance fit, the size of limit for matching part are so selected that the clearance between them away occurs, and it may be noted that in clearance fit, the tolerance zone of the hole is entirely above the tolerance zone of shaft. Now, what do you mean by this? So, here in clearance fit, what happens? The tolerance zone of hole is entirely above the tolerance zone of shaft. And in interference fit, what will happen? The tolerance zone will be entirely below the tolerance zone of shaft. So again, here it is written that the difference between minimum size of hole and maximum size of hole is known as the minimum clearance. Here, what is minimum clearance? Here it is defined the difference between the minimum size of hole. So the minimum size of hole is, suppose this is the minimum size of hole, and the maximum size of shaft. Here it is the maximum size of shaft. So we will get a difference that is called as the minimum difference. Whereas the difference between the maximum size of hole, here it is the maximum size of hole, and the minimum size of shaft, that is called as the maximum clearance. So here we have defined two terms. First one is the maximum clearance and second one is the minimum clearance. So maximum clearance is the difference between the maximum size of hole and minimum size of shaft, while the minimum clearance is the difference between the minimum size of hole and maximum size of shaft. Remember this, the hole we take the, for maximum clearance we take hole size as maximum, and for minimum clearance we take hole size as minimum, while for shaft it is completely opposite. For maximum clearance it is taken as the minimum shaft size, and for minimum clearance it is taken as the maximum size of shaft. Then we can get this type of two clearance. Now the clearance fit may be slide fit, easy sliding, running fit, or slack running fit, or loose running fit. Because there is gap between the two parts, so it will be one type of sliding or running fit. Second one over here is the interference fit. So same way, the completely opposite of clearance fit is the interference fit, and in interference fit, the difference between the maximum size of hole and minimum size of shaft is known as the minimum interference. So here the things becomes opposite of that. In that we get the maximum size of hole and minimum size of shaft. We are supposed to get the maximum interference, while here we will get the, sorry, here we will get, in previous we get the maximum clearance for the difference between the maximum size of hole and minimum size of shaft, while here it is dependent on the size of shaft. Now the minimum size of shaft and maximum size of hole, we will get the minimum interference. The shaft side selected is the minimum size, and maximum size of hole, it is the minimum interference, while the maximum interference is the maximum size of shaft and minimum size of hole. So difference between the minimum size of hole and maximum size of shaft is known as the maximum clear interference. Okay. So here the interference may be shrink fit or heavy drive fit or light drive fit. So this is about the interference fit. Now what is transition fit? So the transition fit is a type of fit in which the size limits of matching parts are so selected that the either a clearance or interference may occur depending upon actual size of matching part. Now, what do you mean by this? So here it is not defined that it is a clearance fit or interference fit. All the things depends on the actual size of matching part. When we actually manufacture the part, what we will get, sometimes we get clearance fit, sometimes we get interference fit, sometimes we get perfect fit. So in transition fit, it is transition between, transition means itself, it is the uh, difference between both. So it can be clearance or it can be interference. So it may be noted that the transition fit the tolerance zone of hole and shaft overlap. So यहाँ पे जो दोनों का टॉलरेंस जोन होगा वो यहाँ पे ओवरलैप करेगा. So the transition fit may be force fit, tight fit, and push fit. Okay, so this is about the transition fit. Now there are the basis of limit system, and there we use two types of basis for limit system, that is the whole basis system and shaft basis system. So this is nothing but a simple fundamental for applying the showing the tolerances. First let us discuss what is whole basis system. So when the whole is kept as a constant member, so here in the first diagram, you can see the whole dimensions are kept as a constant, while the shaft is the varying dimension. So when the lower deviation of whole is zero. Now, what is lower deviation? So lower deviation, minimum size and the basic size. Difference between the minimum size and basic size is the lower deviation, and the lower deviation is here 0. So the it is lower deviation is taken as the basic size, and the different types of feeds are obtained by varying the size of shaft. So the size of shaft is varying and the whole size is constant, while the shaft size, if we keep constant, or when the upper deviation of the shaft is 0, upper deviation of shaft is 0 means, which means the maximum size is equal to the basic size, and the difference between the feet are obtained by varying the whole size. So the whole size is varied, then the limit system is said to be on the shaft basis system. Now remember the difference between both. In whole basis system, the lower deviation is 0, मतलब जो कम से कम जो डायमेंशन यहाँ पे है वो जीरो लिया गया है. दैट मीन्स द बेसिक साइज विल बी इक्वल टू द मिनिमम साइज ऑफ होल. जबकि शाफ्ट बेसिस सिस्टम में अपर डेविएशन लिया गया है, मतलब जो शाफ्ट की जो मैक्सिमम साइज है वो बेसिक साइज के तौर पे ली जाएगी, और वहाँ से हम वो वैल्यू हम कांस्टेंट रखेंगे. जो मैक्सिमम साइज की शाफ्ट है वो लेंगे, जबकि होल बेसिस सिस्टम में मिनिमम साइज की शाफ्ट जो है वो हम सिलेक्ट करेंगे. So this is about the basis of limit system. So this is it for today's lecture. Thank you very much for listening me carefully. Have a nice day.